Alright guys, today we're looking at lesson 12.1 and we're going to start with task 1. Transform exponential functions. Alright, so it says a parent exponential function. So you have a parent exponential function of the form f of x equals b to the x power with base greater than 1 and b is between 0 and 1. Remember, it's exponential growth if it's greater than 1, and it's exponential decay if it's between 0 and 1. So it says the function f of x equals b to the x is a parent exponential function. There is no single parent exponential function because each value of b defines a different parent function. Two reference points on the graph of a parent exponential function are 0, 1 and 1b. So 0, 1 is your y-intercept. You can see whether it's growth or decay. The parent functions are going through this point 0, 1. And they have other points, which these are called your reference points, 1 and your b value. So it says the graph of two exponential functions are shown. We can see that the red is exponential decay and the blue is exponential growth. So it says complete the statements regarding the equations for the functions shown. The reference points, okay, so this is your y-intercept, and your two reference points would be these 2 points here. So 1, 2, and 1 and 0.5. Allow you to determine the base of the parent exponential function because f of 1 equals anything to the first power equals itself. All right, so the equation 2 to the x, and this one would be 1/2 to the x, 1/2 is the same as the 0.5 here, are shown on the graphs. All right, so it says complete the statements. All parent exponential functions share a reference point, and that's going to be your reference point here, 0, 1. And that's because anything, again, to the 0 power equals 1. Properties of exponents. All right, so it says which statements are true. Select all that apply. So the function f of x equals 2 to the x is an exponential growth because the value of the function increases as x increases. That's true, and when b is greater than 1, this is exponential growth. All right, so it says that the function 0.5 to the x is exponential growth. We don't need to go any further because we know 0.5 is between 0 and 1, so this one would be a decay instead of growth. So this one says the function 2 to the x is a decay. That's not true. We've already determined it was growth. And the function g of x equals 0.5 to the x is an exponential decay. We know that's true because this is between 0 and 1. All right, because the value decreases as x decreases. That's true. And again, you can look at that on the graph as well. You can see that this one goes up, and you can see that this one goes down. All right, that's all for task 1. If you have any questions, let me know. Lesson 12.1, task 2. All right, transformations of exponential functions. The graph of the function g of x equals b to the x plus k, where k is a real number, is a translation of the graph of the parent exponential function f of x equals b to the x power. The graph of the parent exponential function f of x equals 2 to the x is shown along with graphs of two other exponential functions g and h. All right, so they're labeled here. F of x is in blue. That is your parent function, f of x equals 2 to the x power, and then it shows g of x is up and h of x has moved down. All right, so it says complete the statements describing how the graphs of the parent exponential function f is transformed to produce g and h. So if you look right here, we're on 1 and it goes up 1, 2, 3, and this one goes down 1, 2, 3. So the graph of f is translated up 3 to produce g, and the graph of f is translated down 3 to produce h. So again, it's just taking the parent function, shifting it up 3, and then shifting it down 3, and that gives you 3, functions in a family of functions where the parent function is f. All right, so let's compare the statements concerning the value of k in the transformed functions. The value of k is just the number that's moving up or down. Okay, so it's transforming this function. So the value of k for the function g goes up 3, and the value for h goes down 3, so it'd be negative 3. The value of k is the difference of the y value, that is translated point, of the corresponding reference point. So again, it's just shifting you up or down on the y-axis. All right, so it says which equation represents the function, or which equations represent the functions whose graphs are shown. Select all that apply. So we know we started with 2 to the x power, and g of x moved up 3, and h of x moved down 3. All right, and don't let this confuse you, because this is the y-intercept, and because this crosses at 4 and this crosses at negative 2, that's still been shifted down 1, 2, 3, and this one's been shifted up 1, 2, 3. So don't let those values trick you up, okay, because they often do that. Put commonly missed answers in for kids to make sure you have to think really what is happening to that function. All right, so it says which statements about the domain, the range, and the end behavior of f, g, and h are true. All right, so it says all three functions have the same domain. That's true. They go left and right forever. That's your x's is your domain, so that's true. It says the three functions have the same range. That's not true, because when you shift up and down on the y-axis, that means your transform functions have a different range than your parent functions. All three functions approach infinity as x approaches infinity. So this is saying as x goes to the right, your y values go up. Is that true? As x goes to the right, as x goes to infinity, your y values go to infinity as well. So that one is true. And it says all three functions approach 0 as x approaches negative infinity. That's not true, because again, oh wait a minute, let's see. All three functions approach 0 as x approaches negative infinity. So as x goes to the left, what's happening? All right, as x goes to the left, this one's approaching 0, but again, the isotopes have shifted because it's translated. So that one is not true. And then it says the value of k affects the end behavior in both directions. That is not true, but the value of k affects the range. So this one is true. Remember, the range is your y values, and on the graph it shifted one function up and it shifted the other function down. So those are your correct choices for that one. All right, that's all for task 2. If you have any questions, please let me know. Lesson 12.1, task 3. The graph of g of x equals a times b to the x power, where a is a non-zero real number, is a vertical stretch or a vertical compression of the graph of the parent exponential function f of x equals b to the x. The graph of the parent exponential function f of x equals 2x is shown, along with graphs of two other exponential functions g and h. All right, so you can see f of x is in blue. F of x is your parent function here. All right, and it shows that there are two other functions. G shows g is in red here, okay, and h is in green. All right, so it says which statements describe the transformations performed on the graph of the parent function to result in the graph of g and h. Select all that apply. All right, so we can see which statement describes the transformations performed on the graph of the parent function f to result in the graphs of g and h. So we can look at the graph and determine which ones are true. So it says the graph of g is formed by applying a vertical stretch by a factor of 2, and then reflecting it over the x-axis. Okay, so we can see that it's definitely been reflected, and we can see that this went up by 2. So we can say this one is true. The graph of G is formed. Well, this one's not going to be true if this one's true. So skip down here. The graph of H is formed by applying a vertical stretch by a factor of 2. And the graph of F, or to the graph of F, sorry. So the graph of H is formed by a vertical stretch, okay, here. So it's going from 1 to 0.5. So that would be considered a compression instead of a stretch. So the H is formed by applying a vertical compression by a factor of 2, and that's why it is 1/2. All right, so it says complete the statements regarding the values of A for the functions G and H. To find the value of A in each function, A times B to the x power and h of x equals A times 2 to the x, compare the y coordinates of the points of G and H that correspond to the reference points on the graph of the parent function. So when I was looking at the graphs to see which one, I was looking at the y values. So the 0.5 and the -2 is what tells me what did that. So that comes from your y value. Remember, every ordered pair is x comma y. So the value of A for G would be -2, and the reason is G is upside down. So because it's going down, that means it's been reflected across the x-axis as well. So even though we show here that it has a stretch of 2, it also has been reflected across the x-axis. And the value of A for H is 1/2 because, again, it had a 0.5. When we looked at it right here, this y value is 0.5. All right, it says complete the statements regarding the equations for functions G and H. So the equation for function G would be -2 times 2 to the x. Remember, 2 to the x was our parent function, and then our A value we found to be -2. And for H, the parent function is still 2 to the x power, and H we found to be 1/2 times 2 to the x power. Which statement about these three functions are true? And if it's hard for you to look at those pictures and try to identify this, you can always graph these on your graphing calculator and see if it lines up with the graphs in the picture. All right, which statements about these three functions are true? Select all that apply. All right, so the domain of all functions, f, g, and h is real numbers. Okay, that's true. They all go left and right forever. So it says the domain is the set of integers. That one's not true. This one's true. And this one says the functions f, g, and h approach 0 as x goes to -infinity. All right, so let's look at the picture. As x goes negative, as x goes to the left, it's going towards -infinity. You can tell because the x values are decreasing. All three of these functions look like they approach 0, so that one would be true. And it says the range of the functions is all values greater than 0. That one's not going to be true because when you move or when you reflect it across the axis, the one got reflected, it's not going to be greater than 0. So we've got functions f, g, and h approach -infinity as x goes to +infinity. So this says as it goes to the right, all three of these graphs go up. Do all three graphs go up? No, only two graphs go up, and g goes down. So that one's not true. All three of them do not go towards infinity. And this one says, as f and h go to infinity,